Okay, so we've seen that different elements have different properties. One property that we're going to focus on is density. Okay, so density is going to be the amount of matter per given space. In other words, density is equal to mass divided by volume. Okay, so these are examples of density here, right? This is a certain volume and it has a mass inside of it. These have different masses, so they would have different densities. My units for density are grams per centimeters cubed or grams per milliliters. So what is density? Density is how tightly packed molecules are within a certain volume. So for example, something like this would have a low density, whereas something like this would have a high density because the particles are very tightly packed together. Okay, so if we look at the simple example, what is more dense? Well, what's more tightly packed? It would be the one on the right. Things are more tightly packed together. Okay. All right, so let's look at the relationship between floating and density. Okay, so if we notice this is a huge boat, right? So it has a huge mass. So even though you have a huge mass, you can still float. Why? Because floating doesn't depend on mass, it depends on density. Okay, so let's look at that relationship. So if I have, for example, let's say I have this here. So the density of water, let's write this here. Density of water is 1 gram per milliliter. Okay, that's the density of water. This object here that's floating would have a density of, let's say, 0.5 grams per milliliter. In other words, when you're floating, your density is less than water. This is inside of the water, so it means it has very similar. So it'll probably have a density of about, let's say something like 1.1 grams per milliliter, right? Almost similar to that of water. So float inside of it. However, if your density is extremely larger than, or it doesn't have to be extremely large, but larger than 1, such as, let's say this here, it has a density of 2, then you will sink 2 grams per milliliter. Okay? All right, let's go back to this example. So that means that this boat here, it must have a density of less than 1 because it is floating. Okay, so and then looking into liquids have different densities as well, right? If you've ever put oil and water together, they separate into different layers due to density. That's density and also due to some polar and nonpolar properties, but we won't go into that. So things that have the highest density go in the bottom, and things that have the lowest density tend to be on top when we have a column like this. So for example, we have these different densities and we have to label them. Okay, so the biggest density here is 10. So which one would that be? That would be the lowest one. So this would have a density of 10. Next one is 6. Then we have a density of 5. And the lowest density would be 3, would go on top. Okay, so things that have the highest density always go on the bottom. Okay, last thing we want to remember is that density it's a property of a material. In other words, if I don't change my type of material, I don't change my density. So let's look at an example here. So here I have a piece of, let's say I have water, right? It's a cube of water. It has a density of 1. Let's say I have a bigger cube of water. Would my density go up? It shouldn't because it's the same material. So let's do the math. Density is mass divided by volume. Here, this is my mass. This is my volume. So 8 divided by 8, well, that's going to give me a density of 1. So it doesn't matter if things get bigger because density is mass divided by volume. Okay, and if my mass goes up, my volume is going to go up and it's going to stay the same. Okay, same thing here. Though. So I have a block with a density of 0.5, right? When I make that bigger, my mass is 4. My mass is 4 now here, right? But my volume is 8. 4 divided by 8 gives us 0.5, which is our density. So if you have, for example, this piece of gold and you cut it in half, both pieces will have this density because density depends on the type of material, not necessarily on the mass and volume. It depends on both mass and volume. Okay, so that's it for the density concepts, and you have another video on how to do calculations.